Hello everyone and welcome to the coding lecture for dictionaries. So with strings and lists, we've been learning about sequences in Python, but now we're going to switch gears and learn about mappings in Python. So if you're familiar with other languages, you can sort of think of dictionaries in Python as a hash table. So right now I have opened the Jupyter notebook and we're going to be going over how to construct a dictionary, various ways to access objects from a dictionary, learn about nesting of dictionaries just like we learned about nesting of lists, and then we'll learn about a few of the basic dictionary methods. Okay, so let's go ahead and get started with the code. So like I mentioned earlier, dictionaries in Python are mappings, and what mappings basically are is just a collection of objects that are sorted by a key. So unlike a sequence that stores objects by their relative position, so if you remember in a list, for example, I can make a list L, 1, 2, 3. So remember, I could access things from that list by indexing. So that's how a sequence works. What a mapping is going to do is it's going to store objects with a key. So it's an important distinction since mappings aren't going to retain order like lists and strings did. So let's go ahead and see how we can construct a dictionary. So in Python, a dictionary consists of a key and then an associated value. And the value can be pretty much any Python object. So I'll make my first example dictionary by saying my_dict as the variable name. And we make dictionaries in Python with curly brackets. So if you just put shift above your square brackets, you should get these curly brackets on your keyboard. And then the way we can construct a dictionary is, the most basic example is you put in a key name, usually a string, pretty much always a string, and then what the value you want. So in this case, I'm going to put in values, and there's a colon separating the key and the value. And then we have commas separating the various key and value combos in our dictionary. So then I'm going to put colon and put in value 2. So this is probably the most basic version of a dictionary you can have in Python. So if you notice, the way we construct it is I have these curly brackets, and then I have a key, colon, and the value that's associated with that key, and then comma for every key value combo throughout that dictionary. So if you remember, we could use square brackets to access index elements in lists and strings. In this case, we're going to use the keys for a dictionary with the same bracket notation. So I have this bracket notation, but if you notice, if I put 0, it's not going to work. It's going to say key error. And that's because it's not a sequence, it's a mapping. So what I end up putting is the key instead. So if I put in key 1, it outputs the value that's associated with that key. So another important note is that dictionaries, just like lists, are super flexible in the type of data types they can hold. So for example, I can get my_dict, and I'm going to create a new dictionary now. I'll put k1 for key 1. And I can put a number, such as like an integer. I can also mix data types, so I can say key2 colon, put in a floating point number there, and let's say k3, I can set that equal to a string. Close off with another curly brackets. And so now I can say my_dict, and I can call any one of those keys, and it will return the value associated with that key. So let's try calling another item. Let's try getting that third key out there, which is string. Cool. So what's really interesting now is, based on the value that gets outputted from that key, I can then call different methods on that value. So right now, if you notice, my_dict with the k3 key is this string, which is also labeled string there. So I can actually perform different things that I'd be able to do on a string, such as index, which would output s there, or maybe I could reverse it like we did for strings, which is colon colon -1. And then I can even call different methods, so I can say maybe like upper method, if you remember, uppercase. So what this is basically doing is it's returning that string, and I can do anything I want with that object that I'd be able to normally do with a string. Great. So we can also affect the values of a key as well. So for instance, right now, if you notice, my_dict K1, remember that square brackets, that K1 key, is equal to 1, 2, 3. So if I say K1, let's say 1, 2, 3 minus, let's say 120, that's going to be equal to 3. So that makes sense. Right now I'm just calling that number and subtracting 120 from it. But if I, let's say, copy and paste this, you'll notice it doesn't actually affect that value permanently. But what I can do to affect that value permanently is use an equal sign. So I can say my underscore dict of K1 is equal to my underscore dict K1 minus 120. And now what that's done is it's actually changed the value that's associated with that key. And so now it equals 3 permanently. So now if I print out my dictionary just by calling it, you'll notice that I've permanently affected the value associated with that K1, that first key. Cool. Alright, so now what I want to mention is that you'll notice while you're doing your various coding exercises throughout the course, you may be trying to do this type of operation a lot. This take a value, set it equal to either addition or subtraction from the value itself. So some sort of self-subtraction or self-addition, or even like a multiplication or division. So what's really nice about Python is it actually has a quick syntax for you to do self-subtraction or self-addition or multiplication and division. And what that looks like is you basically put the operation before the equal sign. And I'll show you a quick example of what I mean. So remember, right now we have my dict, the K1 key is equal to 3. So if I say my dict K1, K1 plus 100, now it's going to be equal to 103. So I can use a quick syntax to do this, to basically fast forward through this notation. And the way that works is I end up taking this plus sign here, putting it behind the equal sign, and then get rid of this notation there that's self-referencing it. So this is the exact same thing that plus minus performs the exact operation that we just did before. And you'll notice since I ran both these cells, now it's at 203. So you can go ahead and check out the Jupyter notebook for some other examples. So for instance, if I wanted to do a self-subtraction, I just do minus equals and then the number I want to subtract itself from. You can also do multiplication equals and then division equals as well. Great. So that's just a nice syntax so you don't waste a lot of time rewriting the same object over and over again. So I can just say minus equal and then 120 here in this case. Alright, so moving along, we can also create keys by assignment. So for instance, if we started off with an empty dictionary, we could continually add to it. So I'll show you what I mean by that. I'm going to make a label or a variable called D, and I'm going to create an empty dictionary. And I can create an empty dictionary just by putting curly brackets with nothing inside them. So D is now just an empty dictionary. So the way I can create a new key is through assignment. And the way I do that is I can say D, and we'll have the key be called animal in this case. And I'll set it equal to a value. In this case, I'll have it be equal to dog. And we can do this for any type of object. So I could say again, let's say D answer for a key, and I can set this equal to 42, for instance. And now if I check out what my dictionary looks like, I've actually added in those keys and the values associated with them. So this is how you can add new keys and new values to your dictionary through this sort of assignment. Okay, so now we'll look into nesting with dictionaries. So hopefully you've seen right now that Python is super flexible with nesting objects and calling methods on them. So now we're going to look at a quick example of a dictionary nested inside a dictionary. So remember we were able to nest lists, so we can actually do the same thing with dictionaries. So I can say D is equal to, and we'll make, let's say, K1 be one of the keys, colon, and in this case, that K1 key is going to refer to another dictionary. So let me close off that first dictionary, and now I'm going to have another dictionary. I'm going to call this key nest key. And to show you how deep we could go, we could even create another dictionary inside that one, and then say like subnest key, colon, and then let's just put a string in called value there. And you notice this is almost like quite an inception of dictionaries. So how can we grab that value, this string right here? How do we go about doing that? So first off, I have my dictionary, and my dictionary actually only consists of one key, K1, this most outer dictionary. And the rest of it is just dictionaries nested inside. So if I say DK1, what does that return? That returns those two nested dictionaries. So I can go again and say nest key off of that return dictionary, and now I have that subnest key in that value. And then one more time, I can say subnest key, and finally I get out that value. And then again, I can call different methods on it. So I could say upper, and then it returns a capitalized version of value. So hopefully you can see just how powerful nesting with dictionaries could be within your code. So you're probably never going to go this deep for basic codes, but it is really useful to go at least one nest deep as you get better at programming. Okay, so what we're going to do now is go over a few of the dictionary methods that are built in. So let's go ahead and create a new dictionary. I'm going to say, I'm actually just going to call an empty dictionary to go over how we can construct it again. So I'll say K1 is equal to 1. I'll say D of key 2, so K2 is equal to 2. And then I'll make one more key, and I'll have its associated value be 3. And now if I check out what my D, that dictionary, is equal to, it's equal to K1 of 1, K2 2, K3 3. Great. So now I have my full mapping, where I have 3 keys, K1, K2, K3, and then 3 values associated with each of those keys, 1, 2, and 3, respectively. Okay, so there's different methods. If I put D, and since I'm using Jupyter Notebook, I can actually click Tab, and these are a bunch of the different methods that are available to us for dictionaries. You can go ahead and check out the Advanced Dictionaries lecture if you want to learn about all of them. But in this case, we're going to look at some of the basic ones. So for instance, D underscore keys, close parentheses, since I'm not adding in any arguments there, will actually return a list of all the keys. And there's a similar method for the values in the dictionary. D.values will return all the values. And you notice here, they're out of order from what we originally printed out that dictionary. And that's important to note because remember, dictionaries are never going to hold a specific order. Since they're mappings, the way they keep track of things is through the keys and the value combinations. So there's no such thing as indexing a mapping. So we could index lists and strings since those are sequences, but we can't index a dictionary. What we'd have to do is call things by its key. So it's not a direct index of like D0, D1, etc. It's you're referencing things by their keys. Okay, so we have D.keys method to grab a list of all the keys, D.values to grab a list of all the values, and if you wanted a combination of those, we can say D.items, and that will return a list of something called tuples, or sometimes called tuples, of all the items. So if you notice here, we have a list, and we have this notation of these parentheses that are all the pair combos. So we'll learn about tuples or tuples in an upcoming lecture. And that's about it as far as just this beginner's introduction to dictionaries. So let's just go over everything we covered in this lecture really quickly. Remember, dictionaries are mappings in Python. They're different than sequences because they don't retain any order. So we refer to the values or the objects within that dictionary through their keys. In order to construct a dictionary, we use this curly bracket notation with the key name, a colon, and then the value name. And then we can call values by their keys using that bracket notation. Continuing along, Dictionaries are super flexible in the data types they can hold. For instance, here I have a list inside of a dictionary, numbers, we can have dictionaries inside of dictionaries, and then you can call items from that dictionary, and then index or methods on those values as well. So we also learned about this quick notation of self-subtraction or addition. Remember, we could do that minus equals instead of doing something like this, which was that object self-reference minus. So that should save you some time if you're coding. And then to create a new dictionary, you can create new keys through assignment, just like we did here, with that equal sign sort of assignment. And then here's the result. You can nest dictionaries, we went over that, and keep calling the keys to go further and further in those nests. And then we went over a few dictionary methods, the keys, the values, and then items. So hopefully by now you have just a good basic understanding of how to construct dictionaries. There's a lot more to go into here, but we'll be constantly revisiting dictionaries throughout the lectures. All right, great. So let's go ahead and move on to the next lecture.